Okay, this is lesson number 24 on three-dimensional trigonometry. We're going to learn to use right angle trig and the sine law and cosine law to solve problems in 3 dimensions. Usually the strategy is going to be to find a common side or shared side between two different triangles that you're going to need in order to solve the problem. So our first problem says, how high is the balloon? So I'm just going to outline in blue here what it is they're asking us to find. So this distance here in blue would be the height of the balloon from the ground. And this is supposed to be like a triangle that's flat on the ground, and then up to the balloon, and then lines of sight from B and D with angles marked in. So if you look at this bottom triangle that's supposed to be on the ground, we've got the most information out of any of the 1, 2, 3, and then the whole big triangle. That's the most information we have here. We have 2 angles and a side. So, and then we want to look for a common side if we want to end up getting this distance here from A to C, or the height, we could call it, of the balloon above the ground. And you can see that they've shown that this is a right angle between vertical and the triangle that's on the ground. So we've got an angle here. We also have this 64-degree angle. So I'm going to go over this triangle in yellow, this right angle triangle. It doesn't look like a right angle triangle because of the way they've drawn it in 3 dimensions, but it is. So now we're going to look, is there a shared side between this bottom triangle that we know a lot about and this right angle triangle that we will ultimately use to find the height? And hopefully you see it. And it is this side here, CD, the side CD, is shared between the 2 triangles. So we would want to see then, do we have enough information to find that shared side CD? So because we know 2 angles in this triangle that's on the ground, we actually know all 3. So we can just do 180, subtract 50, subtract 56, and that gives us this angle here, which ends up being 74 degrees. So we actually know all 3 angles in the triangle and 1 side, which means we can use the sine law. So if we want to find side CD, let's start off our sine law by saying we want to find side CD there. And the angle opposite side CD is 50 degrees, so if we use the sine law, it would be divided by the sine of 50 degrees. Equals, so the side we know, sides are on top when we're finding a side, over the sine of the angle opposite it. And we determined that that was 74 degrees. So then if we multiply both sides by the sine of 50 degrees, we get that CD is approximately 159.38, so we're going to use this side again, so I'll keep an extra decimal place, so 159.38 meters. So that's our shared side. So now if we're just looking at this yellow triangle here, we're thinking, okay, it's a 90-degree triangle because they've outlined that 90-degree angle for us. So if we label the sides according to this acute angle here, the side we want to find, H, is the opposite side, the height. And the side we just found out is not across from the right angle, so it's the adjacent side. CD is the adjacent side. And then, knowing our right angle trigonometry, the formula that involves opposite and adjacent is tan. So remembering back that the tan of an angle is the length of its opposite side divided by the length of the adjacent side, we can apply that to this yellow right triangle here. So the tan of 64 degrees is the length of the opposite side, which is what we're trying to find, the height of the balloon above the ground, over the adjacent side, which we calculated to be about 159.38 meters. Multiply both sides by 159.38. And we'll get a value for the height of the balloon above the ground. So I'm doing 159.38 times the tangent of 64 And you get 326.8 approximately. And look for units meters. And since it's a word problem, we'll add a little statement there. Therefore, the balloon is 326.8 meters above the ground. Okay, so there's our first question in three-dimensional trigonometry. And we did use that technique of finding a common side or a shared side between two triangles. So we'll go on to our next question here. This one again, they give us a diagram and ask us how tall the tree is to the nearest meter. So again, we have this triangle that's on the ground. It looks like it's crossing a river as well. And then we have another triangle that's straight up and down vertical that involves the height of the tree, which is what we're asked to find here, or C to D. So that's ultimately what we want to find. And we're going to assume, and they even show us, that the tree and the ground are 90 degrees to each other. So that's a 90-degree angle in there. And then we have this triangle on the ground. You can see that's the triangle A to D to B, where we know two angles aside, so we really know all three angles. We can get that angle in there by doing 180 minus 60 minus 80, which gives us 40 degrees for this angle up here. And then we want to look for what side is shared between the two triangles that we're talking about. So we have this triangle on the ground, and then we have this triangle that contains our CD, or the height that we want. And so you can see I went over this B to D in both of the triangles. So that's the shared side that we want to find first. Okay, so first we're going to find that shared side. And it's not a 90-degree triangle that's on the ground, so SOHCAHTOA is out. But we know all three angles and a side, so we can use the sine law. So we want to find this side BD here. So I'm going to start off by saying we want to find side BD, dividing it by the sine of the side opposite. So that would be the sine of 60 degrees, is equal to the side we know in that triangle, 400 meters, divided by the sine of its opposite angle, which we determined was 40 degrees. Multiply both sides by the sine of 60 so that we can isolate BD. So I'm doing 400 times the sine of 60 degrees divided by the sine of 40 degrees. And we end up getting 538.92. Just keeping an extra decimal place because I'm going to use that number again, meters. Okay, so now I'm looking at the triangle, I'll outline it in blue, that contains the height of the tree. And it is a right triangle because we see the 90-degree angle there. We also, fortunately, are given this angle at the bottom to be 20 degrees. So if we label our sides according to the acute angle 20, the side opposite 20 is CD, that's the height of the tree that we want to know. We could call it height. And we just found out that common side BD to be 538.92. So according to the 20 degrees, H is the opposite side, and the 538.92 is the adjacent side. So it's going to turn out to be tangent again, because opposite and adjacent are involved. So we can do the tan of the angle, which is 20 degrees, is equal to the length of the opposite side, which is H, over the length of the hypotenuse, which is 538.92. And then we want to get H by itself, so we're going to multiply both sides by 538.92. And then use our calculator. So 538.92 multiplied by the tangent of 20 degrees, 196.2 approximately, but it says nearest meter here, so that's just 196, approximately 196 meters. So therefore the tree very tall tree, is 196 meters tall to the nearest meter. Okay, so there's two problems that involve 3 dimensions. Here's another one. So this kind of looks like it's folding in. That's what makes this one look kind of 3-dimensional here. They want us to find x over here to the nearest 1/10 of a centimeter. And we've got 2 right angle triangles, so right angle trigonometry is going to be involved. And in triangle DEF, which is, I'll go over in yellow, that's the one we know a little bit more information about because we're given not only the 2 angles, which means all 3 angles, but we're given this side of 15 centimeters. And the shared side between the triangle that contains x and the first triangle here is going to be this DF side. That's going to be my shared side. So that's the side that I would want to find out. So again, knowing this is a right angle triangle, SOHCAHTOA comes into play. So if I want to find this side here, the opposite side, it's going to be involved. And the side I know is the adjacent side. So it's going to be tangent yet again. So I can say the tangent of the angle, which is 35 degrees, is equal to the opposite side, which we could just call DF, over the adjacent side, which is 15 centimeters. Again, simply just multiply both sides by 15, and we get the length of DF. So 15 times the tangent of 35 degrees, 10.5. 0, so 10.5 centimeters approximately. So now we can come over and look at the triangle that does contain x, also a 90-degree triangle told to us with a 45-degree angle. And again, according to the 45-degree angle, the side DF that we just found is the opposite side, but this time it's the hypotenuse that we want to find. So we've got opposite and hypotenuse involved this time. So that's going to be the sine ratio. So we can do the sine of the angle, which is 45 degrees, is equal to the length of the opposite side, which we just found to be 10.5, over the length of the hypotenuse, which is x. So this is the case where the variable or x that we want to find is in the denominator. So we would start off by multiplying both sides by x to get it into the numerator. And then dividing both sides by the sine of 45 degrees. So we've got 10.5 divided by the sine of 45. And that's going to give us 14.8 centimeters, approximately. And then just make sure to the nearest 1/10 of a centimeter, put a little therefore sign in front of x. That's all they wanted us to find. So we're done that problem. Again, it involved finding a common side. Next question. How high is the cliff? Okay, so H, they've marked it on. That's what we want to find. They've shown that it's a right angle triangle. So this CDB triangle is flat on the ground, and then the CAB triangle is vertical. So that's why there's that 90-degree angle between the 2 triangles there for us. The triangle on the ground, we know 2 angles, so we actually know all 3 angles. We can figure that one out quickly. 180 minus 42 minus 63 gives us 75 degrees here. And we know one side, so we can use the sine law. But we want to use the sine law effectively. We want to use it to find something we need, which would be the shared side, which hopefully you're good at spying by now, is going to be this side CB, because it's in both triangles, the one that we need to find the height and the one that we have the most information about. So if that's the side we want to find, we want to start with the side on top. So it could be called side BC, over the sine of its opposite angle, which is 42 degrees, is equal to the side we know, 68.5 meters, over the sine of its opposite angle, which we just figured out was 75 degrees. Then we want to solve for BC by multiplying both sides by the sine of 42 degrees. And we get that BC is approximately, so I'm doing 68.5 times the sine of 42 degrees equals divided by the sine of 75 degrees. And you get 47.45. It's not our final answer, so we can keep that extra decimal place, meters. And now we know this BC side here that we need to get the height of the cliff. So now, according to this 38, the acute angle in our right angle triangle, the opposite side is H that we want to find, and then BC is going to be our adjacent side. Opposite and adjacent is tangent ratio. So the tangent of angle 38 degrees is equal to the opposite side, H, over the adjacent side, which was BC, and we just found out that was 47.45 approximately. We want to get H by itself. So we can multiply both sides by 47.45. And we get the height of the cliff to be approximately, so 47.45 multiplied by the tangent of 38 degrees equals about 37.1 meters. And then we'll answer the question. So therefore, the cliff is approximately 37.1 meters high. Okay, so again, shared side, very similar strategy for all of these questions that we've completed. Last question. So this says, what is the distance from A to B? Again, you can see it does look like a three-dimensional diagram with like two right triangles, and then this middle part connecting A and B, so two poles basically, and then we want to know how far apart they are from these given measurements, to maybe P stands for a person out here making these measurements. So in this case, A to B is part of this triangle here. And the only thing we know about this triangle is that angle there, 42 degrees. That's the only thing we know. So we're going to need to know a lot more in order to be able to find the distance from A to B. So let's look at these triangles that are on the outside. First of all, this one's a right triangle, which is great. And we know an angle and a side. So this side here, A to P, is something we need to know. It's another piece of information we can find out about this central triangle here. So let's say that we want to find it. So according to the 23 degrees, this side would be the opposite side. This side we want to find out is the hypotenuse, and then the other side is going to be the adjacent side. So we can cross out the opposite because we don't know it, nor are we trying to find it. So adjacent and hypotenuse are going to be involved in our calculation, which means we're going to use the cos ratio. So the cos of the angle 23 degrees is equal to the adjacent, which is 18, divided by the hypotenuse. We don't know it, but we could call it side AP. And then we want to solve for side AP. So we're going to multiply both sides to get it into the numerator by side AP. We have side AP is times the cos of 23 degrees is 18. And then to get that side by itself, divide both sides by the cosine of 23 degrees. So we end up getting that AP is approximately, So 18 divided by the cosine of 23 degrees gives me approximately 19.5, 19.6 meters. All right, so now we've got one of our sides here, 19.6 meters, and an angle. Still not enough information to calculate the distance from A to B. So let's go over to our other right triangle now, this one over here. Again, we know a side and we know an angle, and we could find this other side that we need for the middle triangle, BP. So according to the 18 degrees, 7 meters would be the opposite side. And then the side across from the right angle, BP is our hypotenuse. So we want the ratio that has the right angle trig ratio that has opposite and hypotenuse in it, and that's sine. So we can say the sine of angle 18 degrees is equal to the opposite side, which is 7, over the hypotenuse BP, which we're trying to find. So opposite over hypotenuse, so we're going to multiply both sides by BP to get it into the numerator. And then divide both sides by the sine of 18 degrees to figure out the length of side BP. Seven divided by the sine of 18 degrees turns out to be 22.7, say, meters. And you can already see we're keeping an extra decimal place compared to like plane 18 and plane 7 to make our answer a bit more accurate. So now we know for this triangle that's not a right angle triangle, ABP, we know this side, 22.7, 42, and 19.6. So two sides in the contained angle, side, which gives us enough information to use the cosine law to find the length of AB here that we need. So if we're going to use the cosine law, I would start off with the side I want to know here. We could call it little p squared equals, so the other two sides squared, 19.6 squared plus 22.7 squared, minus 2 times 19.6 times 22.7 times the cosine of the angle between them, which is 42 degrees. Some people may be able to go straight to the answer now. But I'm going to at least type all of this in. So 19.6 squared plus 22.7 squared minus 2 times 19.6 times 22.7 times the cosine of 42 degrees. So that gives us 238.1700. But that's the square of the side we want. So we want to square root both sides. So P is approximately 15.4 meters. So therefore, the distance from A to B is 15.4 meters. So that's how you approach 3D trig problems. You look for shared sides. You use information from oblique or right angle triangles to gather enough information to solve for what it is that you need. Our success criteria are that we can use trigonometry effectively to find missing sides or angles in three-dimensional diagrams, and understanding that a common strategy to look for is to look for a shared side, and that most questions will involve more than one triangle, more than one calculation. Okay, you're done.